Whether to use a standard neural network or a deep neural network, DNN. Pradeep K. Suri. Author and researcher. Depends on the complexity and nature of the problem you're trying to solve, as well as the availability of data, computational resources, and your specific goals. Here are some guidelines to help you decide. Standard neural network. 1. Simple data and tasks. If your dataset and the problem you're solving are relatively simple, a standard neural network might suffice. For example, tasks like binary classification on well-separated data, linear regression, or simple function approximation might not require the complexity of a deep architecture. 2. Limited data. If you have limited data available for training, a simpler neural network can help prevent overfitting. Deep neural networks tend to require larger datasets to generalize effectively. 3. Computational resources. Training deep neural networks can be computationally intensive and time-consuming. If you have limited computational resources, using a standard neural network could be more feasible. Deep neural network, DNN. 1. Complex data and tasks. DNNs excel when dealing with complex and high-dimensional data. Tasks like image recognition, natural language processing, and speech synthesis typically benefit from the hierarchical feature extraction capabilities of deep architectures. 2. Hierarchical features. If your problem requires learning hierarchical features or representations of the data, deep neural networks are better suited. They can automatically learn to represent abstract features through multiple layers. 3. Large data. Deep neural networks can leverage large datasets effectively. With more data, they can learn intricate patterns and generalize better, leading to improved performance. 4. State-of-the-art performance. In many domains, deep neural networks have achieved state-of-the-art results due to their ability to capture intricate patterns. If your goal is to achieve the best possible performance, a DNN might be the way to go. 5. Transfer learning. Deep neural networks are often used for transfer learning, where a pre-trained model on a related task is fine-tuned for a new task. This leverages the knowledge learned by the model on a larger dataset, saving training time and data requirements. 6. Image, audio, and text data. For modalities like images, audio, and text, deep architectures have shown significant success. Convolutional neural networks, CNNs, for images, recurrent neural networks, RNNs, for sequences, and transformers for natural language are examples of deep architectures tailored to specific types of data. Remember that selecting the appropriate neural network architecture involves experimentation and iteration. You may start with a simpler model and gradually increase its complexity as needed, monitoring its performance on validation data. It's also essential to keep up with the latest research and developments in the field, as new architectures and techniques are continually being proposed.